Hi, my name is Phiri, and I'm going to be presenting an automated mineral ore dispenser. So, in blanket mine, they've got a problem of irregularities in controlling the ore release rate by the manual operation, resulting in extended downtime. So I seek to design a PLC-based control system that automatically opens and closes the chutes based on the weight that is read from the conveyor belt. So basically I want to transform this, which they are currently using, into a more sophisticated and automated system. So in this project, I seek to control the sequential opening and closing of the ore bin chutes. I seek to control the ore feed rate into the ball mill crusher. I hope to reduce the ball mill downtime from 40 hours a week to only 3 hours, and improve the plant efficiency by removing the human operator and replacing him with an automated chute. So I did a case study, did some experiments, and did some programming and model simulation. So in a nutshell, we're going to have an analog signal from the conveyor belt, which has a weightometer on it, feed the signal into a PLC, have some computations from it, then decide on which chute we should open and how wide we should open it. Again, we also have a feedback loop from the chutes back into the PLC to ensure that we are on the right path. So I've got an electrical simulation here that I did in Proteus using an Atmega, Arduino Uno, a motor driver, L32, L293D, and a potentiometer. So the potentiometer is going to be representing the weightometer on the conveyor belt. The Arduino controller is going to be representing the PLC. The motor driver and the motor are going to be representing the chute. So when we open the chute, and we're going to have a reading on the potentiometer, use that reading from the potentiometer and decide using the controller, which is the Arduino Uno. Then the result of that is going to determine whether we are going to be opening the motor or not. So yeah, basically that's it. The motor representing the chute, the Arduino representing the PLC, and the potentiometer representing the weightometer, which is the analog signal. I also did a mechanical simulation, which says the ore coming from the ore bin getting into the conveyor belt, and we can see that the greater impact is on the side, not on the conveyor belt itself, so we're going to be having accurate results. I also have design calculations, which are basically calibrating our weightometer to the PLC. We want to be having a range of 2 milliamps to 16 milliamps instead of 0 to 20 milliamps, so that when we get a 0 reading on our weightometer, we know that there is an error, and the maximum we can get is 200 kgs on that weightometer. We got that value from the data sheets on the weightometer. And we try to simulate this, having a controlled system with people actually opening and closing the chutes. And the results we got are on the top, and the regular results from the regular process are at the bottom. So from this we can see that the critical speed, which revolutions per minute on the ball mill crusher, they are actually higher than what they usually have. We also have the power. The process is now drawing less power as compared to the 215 kilowatts that they usually draw. So this is just a way to show that if we control this system, we can actually save on the power and reduce the downtime. So the cost of this whole project, we can buy a chute online for $1,800, panel cables for $30, and the total will be $1,830. So in conclusion, I recommend the expansion of the current PLC input and output modules to allow more inputs like sensors to monitor the system. I also recommend the integration of the current PLC with other PLCs that are controlling other processes and the introduction of a SCADA system so that the operator can have an overall mining view of the processes happening in the mine. And thank you.